Hello, in this video let us solve this equation. So we have t raised to power t is equal to 11, and here we have to solve for the value of t that will satisfy this given equation. So t is the unknown we are to solve for. Now if we try this method, that okay, let's say we assume that t is equal to 1. Now 1 raised to power 1, right, is equals 1, and this is not equal to 11. Now same thing also, let's say we try 2 raised to power 2, this is equal to 4, and 4 is not equal to 11. Now let's say we continue by trying 3 raised to power 3, right, is equal to 27, and this is not also equal to 11. But then if you look closely, right, the value of 2 raised to power 2, which gives us 4, right, is less than 11. But if you look at 3 raised to power 3, right, which gave us 27, this is greater than 11, right? So that means that the range of values for the value we're looking for as 11 is in between 2 and 3. So that means that let's say we keep on trying, let's say we try 2.1 raised to power 2.1, right? And then we keep on testing it, 2.2 raised to power 2.2, right? Now this will cost us time, okay? But there's a much more easier way for us to solve this. Now let us look into how we can solve this in a much more easier way. So solution. Now we have t raised to power t is equal to 11, right? Now to solve this, we're going to introduce natural logarithm to both sides of the equation. So ln of t raised to power t is equal to ln of 11. Now in this case, right, ln is equal to logarithm to base e, and logarithm is equal to log to base 10. So that means that we can apply the property of logarithm to natural logarithm. Okay, so with that, if you have logarithm of a raised to power b, right, this equals power b, then becomes b, then times logarithm of a. So applying this principle right here, power t then becomes t, then times ln t, which equals to, here is ln 11. Now at this junction, what we're going to do, right, to get the value of t is that we're going to introduce what is called the product log, or it's also called the Lambert W function, or it's also called the omega function. Now you might be wondering, okay, what is all this about? Now let's say you have an expression in this format, a times e raised to power a, right? And you want to simplify this. Once you introduce the Lambert W function w into this expression right here, w right here, what you will get as the value is equal to a. Also, let's say you have an expression like, okay, x times e raised to power x, right? And you want to solve this, okay? Once you introduce the Lambert W function w into this will be equal to x. So in this case, we're going to make t ln t to resemble this expression, such that we can then apply the Lambert W function and solve for the value of t. Okay, so let us do that. Now to do so, right, now let's say you have e raised to power ln x, right? This is equal to x. Why? Because e will cancel ln, leaving you with what? X. Same thing also, if you have e to the power of ln t, this is equal to t. Why? Because e will cancel out ln, remaining, or we are left with t. So in this case, right, you can replace t right here with e to the power of ln t. Okay, so e to the power of ln t is equal to t, right? So in this case, you can bring in e to the power of ln t, right, to replace t. So from here, right, e to the power of ln t, then times, so we have replaced t with e to the power of ln t, then times ln t is equal to 11. So times ln t is equal to ln 11. Now, if you look closely, right, if you look at this expression very well, you see that e is in the second place, right? So we're going to move e to be in the second place, such that ln t comes first. So ln t, then times you have e ln t, right, is equal to ln 11. Now with this, we have made this expression to resemble this format right here. So at this junction, we can then introduce the Lambert W function, right, to both sides of the equation. So introducing w, right, so w into bracket ln t times e to the power of ln t, right, is equal to w in bracket ln 11. Now, following the rule of lambda w function, that if you have lambda w function w of x times e to the power of x, this equals x, right? So in that case, this one right here, you have w in bracket ln t times e to the power of ln t. This then becomes ln t, right? Is equal to, you have w, then in brackets ln 11. Now at this junction, to solve for t, we're going to introduce e to both sides of the equation. So if you bring in e, then power of ln t is equal to e power of w, then ln 11. Such that with this e, we cancel ln, and what you have is t standing alone. So t is equal to, you have e power of w, then ln 11. Now with this is the final solution for the value of t. But if you are confused, okay, why is it that the value of t does not have a decimal number? Well, to get the decimal number, right, simply press in your calculator. The value of t is equal to, you will see e in your calculator, so press e, then you will not see lambda w function, but instead you will see product log. So input product to log, power of product to log, then times ln 11, right, in your calculator. Now if you press this in your calculator, the value that you will get is, you will get t as 2.5557. Now this is the value of t that you will get. So in this case, right, t to the power of t, which equals 11, if you input it as t as 2.5557, so 2.5557 to raise to the power of 2.5557. Once you press this, you will approximately get 11. And with this, ladies and gentlemen, right, we've come to the end of this video. Don't forget to like the video, subscribe to this channel. Okay, thanks for watching. See you in the next video. Bye.